I realized that my dark mode preference doesn't really suit the screen, but, and they're not prepared, I vibed my favorite feature that I ever developed so far. Of course, I don't like Microsoft products, so I present a website and not a PowerPoint. But I can like vibe my theme here. So let's do light. Great. It will probably look a bit crap, so maybe let's reset it if it doesn't work. All right. So good to see so many friends here from different past startups and collaborations and the security space and cool people doing really great things at Mink, etc. Happy that you came. So today I'm gonna vomit my opinions on you of how to write code that actually suits the AI agents to get them to write more autonomously. And my name is Emil. Now you don't see anything because my color thing didn't work, but I've done a few things in the past. Let's actually reset this. I think you'll see better without this. So right now I'm running a startup called OAIZ, where we help people vibe code agents with the workflows in their business. Working with some fun customers today. We recently closed Malmö stad, really fun project and to close in the public sector. And maybe my biggest project before that was Debricked, where I funded that with some people here as well. Building a security tool that we sold to a large American firm a couple of years ago. But today we're going to talk about the agentic loop and how your code fits into that loop and how well it fits in. And right now, we at OAIZ have, last week we achieved 10% autonomous coding. Meaning that from start to finish, we can, in 10% of all merge pull requests, don't have any human in the loop so far at all, besides just merging and pressing OK, I'm merging this. And that has been rising quite steadily for the past couple of weeks. We measure that by we have a separate user on our server that runs our Cloud Code instances, and we see whenever that non-human makes commits, we measure that on the pull requests and see if, when merged, do we have any human contributions on this pull request, and that's where we get that rough 10% autonomy from. And I would argue that it should be a lot of organizations' goal to reach as high autonomy as they possibly can when shipping software, so that you can increase your velocity and take market where you can. But in this agentic loop, it's really, really hard. Let's work back. I'm sorry. No. Let's go back to the thing that looked like Facebook. You have to listen to me. So we have the rough outline of the agentic loop, which is first your prompt, then it orients your code base, and then it retrieves whatever information it can to understand the underlying code base. Then it goes to edit your code base, and then it verifies. And then it kind of roughly goes into this loop. And you can adapt your code base to target some of the specific parts of the agentic loop to improve it. You can have things like adding LSPs, language server protocol, to make it easier to orient and retrieve. You can have architectural docs, and you can improve your naming or domain vocabulary to help it use bash and grep to actually do the retrieval. And today I want to target a few specific things. Namely, let's start with the infamous Agents.md let's talk about some architecture and context bounds. Sub-agents. Let's talk about SDKs and code quality, a hot one. Tests and custom rules in your code base. So if we start off with the Agents.md, when a couple of years ago when we started creating these ones, it was really popular to like, oh, you are a senior engineer, we follow these patterns, write clean code, and trying to get that to work. But there's actually been quite a lot of research on the Agents.md, and it turns out that you should try to keep this behavior-oriented in what the agents should do, not the shape, the code it writes. Meaning that adding your commands there, adding indexes to whatever documentation you have, or good patterns to look at, and so on, and not like patterns to follow that are the vague terms like use domain-driven design or follow these particular patterns, etc., that don't have the explicit knowledge of the next thing to act on in this in the agent. But then this becomes quite small, which is good because you want a lot of context window free for your edits and your retrieval, and not fill this up completely with the agents.md files. So what actually I've seen in research, and we've tried ourselves quite successfully, is to build either documentation where documentation makes sense. If code can document your code, that's usually a lot better. But if there are things that you need to express in text, making that a searchable index and something that's digestible in size that you as a team can quite thoroughly maintain has shown some success here as well. So in your Agents.md, you point to things such as, this is my architecture index, and you can have different files for like, oh, these are the boundaries for this architecture, these are the testing strategy I'm using, this is how I use generate my SDKs, or these are my different policies, to help the agents during retrieval actually navigate and orient in the code base to how to write code. But going to what the code shape typically should look like is something that there has also been quite interesting research on, is that if you have the older patterns of a code base where you can have very, very broad and large file trees that are hard to navigate and hard to have neighboring files from in your edit, that doesn't make sense. That's not relevant to the change you're making. So in one particular folder or in that package, there's a lot of neighboring files that doesn't have anything to do with that particular change you're making. That can bring quite a lot of noise to the underlying agent. So what people are doing is that they are trying to bound those contexts into something called bounded contexts. So splitting your code base into more digestible chunks for the agent that makes sense on its own and can more easily be searched and indexed and understood by your agent. So for instance, here in this example, we have a bounded context on billing, where it contains the vocabulary of how billing works, it contains all the data, and it has its own data access layer, and it can have its own business rules and endpoints to work with, meaning that navigating that part of your code base can become quite easy for the agent, and applying those changes can increase the iteration speed of that loop quite a lot. Does it make sense? And going into sub-agents, when we are on the retrieval step of these agents, we can, to effectively research and understand your code base, I found that sub-agents are actually pretty good at this. We've heard that you can use sub-agents for like implementation if you want to compress the context window, so to have an agent that manages these different sub-agents. But I've found that like a completely different technique where you don't do the implementation in sub-agents. You do the orientation and retrieval in sub-agents. Because the implementation agent doesn't need to know that it had 5 failed greps while trying to navigate your code base and find the different patterns that you actually care about. So delegating that work to sub-agents with its own context window to navigate the code base can be pretty effective in compressing that context window, only returning that explicit information that is relevant to this particular task. When I first tried out sub-agents, I did the exact opposite thing, and it made everything worse. Like here I have a senior front-end engineer, senior Go engineer, and that exploded the problem that sub-agents don't talk to each other. Because then you have distributed edits within those sub-agents that don't have the full picture of the edits or the feature you're trying to implement. So it's about getting that compressed knowledge into the implementation part of your agent has proven really useful to me. And then going into vattendelare, maybe, like code quality. Does this even matter in the future that's getting built for us? I'd argue yes. I think that for the foreseeable future, we are building, if you're building something that has technical challenge to it, that means that you have to have confidence in the code you write, that you have to validate its security, and you have to ship it to customers that care about that as well. I think code quality does matter. And quality means a lot of different things to different people, I think. There are good ways to measure code quality. We have people here from CodeSyn. They're excellent at researching and talking about this and have a good tool for this. And I think code quality right now should mean that the quality of your code compounds the velocity of your agents. Meaning that as your code base grows and becomes more manifested in the patterns and how you do things, that should mean that you should be able to run faster, not slower over time. And if you've vibed over the weekend, I've definitely felt it, where I don't look at the code, I just want the end product, and it goes slower and slower and slower, and then it doesn't work at all. That means that I've not actually kept up the threshold where I can tap into this compounding velocity, so the quality of the code has been way too bad. And I think that's a lot of the experience if you try to ship real products from some of the broader vibe coding platforms as well, that you can get really the instant hits, the endorphins flow through your veins, but then after a while you hit that wall and you can basically do nothing. And here's just an example of side effects versus typed side effects. I think use types if you have to have side effects. But there's actually great research on this, that if you measure code quality and how changes apply, how easy it is to successfully apply a change to that particular code, it turns out that actually matters. So in this research, it is actually from CodeSyn. So we can see that these are the LLM models ranked to how well they did. But this disparity here means that how successful it was to apply the change on low quality code versus high quality code. So here we can see that as we raise the bar in the power of the LLM and even the power of the harness, that difference kind of goes away. And this is like good research, but it's also but it's also done on go ahead.
A small addition just to the top, because it looks like Claude Code is really asynchronous. I mean, it's really important to say that this was a refactoring experiment with it, and this is all about the test pass rates. Claude Code didn't do much with the code. That's the reason why the pass rate is so incredibly high.
I think that's Opus. So I think that's an error. So it's Sonnet and then Opus, isn't it?
No. Both are Sonnet. This is just Sonnet without Claude Code, and this is Claude Code with Sonnet.
Right. And Claude didn't do much change to the code. That's why the pass rate is very high. So that's there is another dimension to a successful refactoring. It's not only about making sure it still passes the test cases.
No.
It's also about making it better. Thank you very much.
No, but thank you for. But I think the point stand, and I think you made the point in your paper as well, that better LLMs are just better at this, and I agree. But I think that like this research was on mostly single files.
Yes, all this single file.
Yeah.
Right, so this is quite trivial problems if you compare it to what's out there in the real world.
Yeah, and I don't think Claude Code or an old Sonnet version aces all my code. Definitely not. But I think, like looking at model power, and that there is some disparity, depending, that you can see disparity between successive edits and underlying code quality. Actually, aligns quite well with my gut feeling in the code bases that I've worked with as well. And I also, it's not only about the successful edits now. Like we talked a bit about that we need to be able, we need to be able to define the specs, and we need to be able to review the code. That's the problem now, not me typing at my keyboard like it was before. And with good quality, I think comes familiarity. And this used to be about technical depth. I think there's a big a thing that's been trending on Twitter for a while, which is cognitive depth, where it's not that you don't, it is that you no longer understand your code base. Actually, I talked to my grandmother, she's 89 years old, and tried to describe this concept, and she described it back to me in a perfect way. It's like, oh, you know your relative, like old relative that's not with us anymore, etc. When we used to go into the barn and we had 1,000 pigs, they could just like go in, have a look, and say, yeah, that pig is not doing very well. We should take a look at that. And she called that having a cow's eye, a koöga, meaning that they can't explain it. They can't put that in a wiki. Claude.md and say, this is how you discover bad cows while standing 30 seconds in a barn. They just had that feeling. And if you worked a while in a code base, I think you get that feeling. That you kind of can extrapolate what you're seeing right now. You have the pattern recognition and can see this is kind of what things can go wrong. This is what usually goes wrong, and this is where I need to spend my time and look at and really dig deeper into that. And this is where I think code quality will matter more in the future, where you will be able to cognitively understand the code that the agent produce. It looks familiar, you understand the code base, it holds up your patterns, and you can easily read it and understand, do I need to do anything? Can I just merge this or whatever? That's where a large part where I think code quality comes into the agentic discussion. Or do you guys from CodeScene have thoughts about why should it matter? Does it matter?
Yeah, well, this is our view as well, obviously, right? That will matter even more.
And let's now we're talked about like how to make successful edits for a while. Let's talk a bit about tests, because I think one reason why coding agents are so successful at that they are right now compared to how AI is penetrating other industries as well is that you have the verification loop. It can reasonably well understand within the context of its environment, have I been successful yet? It can open the browser and look at like, what's the thing I added there? Or is the thing I tried to add there, does my tests pass? Do I have lint errors, etc.? And have that kind of verification loop. And looking at tests, I think there's a quite a big skepticism. Like if AI writes tests, then the tests are worthless. Then it's doing self-verification, and and I can't trust that. And I'm like, no. Then it's an engineering problem that you need to make the AI write good tests that you can verify easily, and then you can hopefully apply some trust to the solution that is built. And the mental model around what tests to write, roughly, now you don't see a lot, but here we have the API layer, we have the domain or whatever is the business logic, and here we have whatever layer interacts with the database, and here we have glue that sits in between. This is like roughly how I'd like to divide up my code bases. I have talking to like external services. I have the important thing that does something and I communicate with external system and I try to glue that together in some way, shape or form. And we have the unit tests. They are maybe not the most valuable part of the test suite, but it helps. But the main point of that is to give the agent its verification loop on the business logic that it's writing. It is possible to verify that, like, oh, here I see the matrix of cases that it should cover of this whatever regex thing or something that you're building there, and that matrix of the test cases looks fine. It's what I expect it to be. And then you can understand the main logic from that, and it's a way for the agent to communicate its intent that it has done. And doing that in these layers where you don't depend on any external service, absolutely. Then we have the adapter tests or integration tests with your underlying data storage. I really use those tests to both make sure that we, from a database layer, don't have tenancy problems, for instance. That each organization cannot access each other things, and try to really have those tests covered there as well. But I think the most valuable thing right now, so this is a bounded context I'm talking about. So this is the billing service. It doesn't need to be a microservice, but it can be like within the code base, this does the billing things and has the billing API, it has the billing database and whatever. But it doesn't concern itself with like the user management or something else. It has that bounded context. Component tests is where you mock everything else external except your direct adapters. Meaning that you do not mock your database that is the billing database for this instance. You can mock the user database or whatever, but within this bounded context, you can test things from the perspective of your API. This has actually been very helpful in our code bases, because then we can kind of test end-to-end behavior without needing to rely on like for us a browser that can be with a playwright test, etc. That can be very slow. It can be error prone. It's hard to set up. It's hard to handle parallel and multiple tests. This is still something that can rely on only like one binary of your code base and be tested, and that's fine. But you can still kind of accurately test user behavior from the API layer. And abstracting making those tests very, very easy for you to understand and read has been a good thing for us. So meaning that I can see that, okay, my first in the test is like, I want to test this user story where I have this intent of achieving this functionality for the user. And then it does maybe 7 API calls to achieve that. And I can follow that along and it achieves that. That's great. But then also achieving like, I want to test that I cannot access the data I shouldn't be able to access. And going through those tests to me where you have the full context of that bounded context. And then of course the end-to-end test. I think the combination of these two, the like pure from the client end-to-end tests and the component tests, are the ones that, like, these are typically the first thing I review when I open a pull request to see that, okay, I understand that I can understand the logic, the agent has to understand how it should behave, and then and if I detect large errors there, I'm usually now I throw away that pull request, rewrite the plan, and then re-implement it.
Do you have any preferences for framework to run this type of tests?
For this one I use Playwright, and like, preference is a strong word. It's the best one I could find. But yeah, preference. But here, I think this depends so much on like your thing. Like we have a Go backend, and this does not. It's not like it's running this in a Dockerized container here. It is written almost like a unit test, like whatever the Go testing framework of flavor you have. But this one is real here, and it's running in Docker, and it's reseeded on with every fixture or whatever you use on every test run, and then writing like helper functions, etc., so that this test can just start its own Postgres instance or Neo4j instance or whatever you use to run those tests. And that, like, if you look at Playwright, like, I don't know, but I mean, then you have multiple seconds at least per test, usually. But this you can not unit test, but not speed, but you can have a very, very high test speed, so it can have this fast iteration loop with almost zero flakes, because it is just it is still the deterministic flow that is not dependent on that a browser. That can be tricky. Yeah, so this is kind of like goes into what people call acceptance testing, and I think this really makes sense for as a starting point for your reviews of the work that Agents has done. The other ones, of course, has value as well, but I think these are the ones I like the most right now. Then. One hill I will absolutely die on is that you should not try to throw JSON over the wall. You should generate your SDKs. So if you have a communication between services or backend, frontend, etc., just lean into OpenAPI spec or gRPC and generate the full thing. Then you get type safety throughout your application, and that also increases the iteration loop of the underlying agent. So for us, what this means is that our backend defines DTOs, so transfer objects that we expose, and that in terms creates an OpenAPI spec, and then we generate the TypeScript frontend, and whatever we go from something, oh, this used to be optional in the backend, but now it's not optional. Then that is directly reflected in the frontend, and TypeScript will not build because we have set undefined somewhere in the code base, and actually not even those the object we return from the API with the DTOs. We don't wrap those in like custom DTOs in the front end. Those are okay to just propagate throughout the front end, because then then it screams that something is wrong when we have broken the API spec. And this is like, we did not do this at my last company. And maybe not the most common error, but we definitely had this this error sometimes. Oh, someone broke we broke our API between the different clients and servers, whatever, and things stopped working. And then also, if you have APIs that customers depend on, it becomes really, really clear when you've broken that contract as well. So, recommend this strongly. And then, I think my favorite thing for last is writing custom lint rules. I've heard of some people doing it, but I don't hear a lot of people doing it yet. And I think working with and understanding how your linters work and codifying the problems the agents are having. Like we've talked about adding things to your Agents.md and it doesn't listen to it or documentation and it just ignores it. What we do instead is that we build custom lint rules with a like straight up prompt injection into Claude when it hits that error and just tells it, oh, you should look at this file instead, or you should go look at this documentation and this is how you behave correctly instead. And just have that iteration loop speed up. And we can, of course, have those kind of patterns and how we want the code quality to quality to be in the Claude MD as well. But this, like, whenever we find something that we get that we can deterministically add to codify like this, it just makes that whole class of errors go away. And I think the realization with this was my friend Felix here. When Claude was really happy adding new colors in our frontend. It really liked the hex, the hex color scheme in random divs everywhere. And I was like, but I mean, that's I don't need to prompt for that. I can just scan the code and find that. So then we extended ESLint to just find that. And like that problem just completely went away. And we also found all our tech debt, fixed that, and then it doesn't do that error anymore. What I've actually done is that we've been like a little bit more sophisticated here and nerdy. My last company was a security startup, so of course I like to build call graphs and stuff like that. So we built a little bit of our own framework here. Where it has access to do like assert, for instance, branch coverage in testing or and things like that. I can just show you. Now we can actually do real light mode. Yeah. Oh wow, a lot better. So. Did you just photo me? So let's just see that it works. So let's just go into our code base, and I think I paled out in the bounded context user. We have our component tests, for instance, and we have our ticketing tests. What I've actually done is that I've created these rules that asserts that all API endpoints has to have a certain shape of the test suite, like with naming and exactly what it tests. It needs to like have one happy path test that goes down and hits every major path of the handlers, so it hits every underlying handler in that API, and it has to have It has to have like unhappy tests where it achieves all possible bad status codes in that API endpoint. So kind of parsing that branch that is really specific to how that works in our code base, that's no problem. And if we just decide to find a test here and just remove a few things here, we can run the linter again. Oh, That was not covered by that. Let's find something else. Let's remove that whole test. Here. So now we can see that it injects Claude with like, oh, this one is not properly tested. You should go read the architecture, README, and find the relevant testing guidelines for this particular test. And that means that we've kind of locked in our opinions about our code base, and tests look similar. So they're easy to read and easy to grasp and understand. And I can just mentally remove all the bloat software and the boilerplate that I don't care about because it looks similar enough, and just focus on the business logic when I actually review. This is one of my favorite things we've done so far to increase the autonomy of our agents. Make sense?
Are you using open source stuff, or have you released some of it open?
Yeah, it's open. So it's this, and it's not to be dependent on. It will probably not work tomorrow, but I think, but it has a skill and to kind of set the mentality for the AI model, and you can just copy that skill and give it to ESLint or whatever you're using, and it will be fine writing really specific rules for your code base. And like why I built this was that the Go scaffolding around our Go code base and those linters are actually pretty bad at giving you the framework part of writing rules, and the linters you have to kind of specify them in YAML or whatever, and I want code, not YAML. So that's why I kind of built this. Yeah. All good. So here's my vibe, the impact to effort. And I think kind of here is like where you get really good payback in your return on investment in your code base with good test rules and SDKs, where to get this autonomous agent working really well and running and successfully in your code base for the long runs. Yeah. Hope you enjoyed this afternoon. Hope you enjoyed the pizza and the beer as well. Thank you very much.
Yes. So nowadays with agents, I know you have the problem or that the agent sometimes searches online. How do you do like end-to-end tests with those kind of things, where the agent needs to be able to go external and be unpredictable?
I think something I didn't talk about here is evals. And I think if you're, like for tests, you want to be able to run them in the CI predictably and get a thumbs up that things are working programmatically. But then you have evals as well. I haven't talked about those at all, but I do a lot of evals. And like a free tip here is to write the tools yourselves for your evals. Don't rely on some external thing that you have to log into a website to do stuff. JSON in your code base and write a CLI that you give Cloud Code to use to be able to run your evals, extract anonymized data from your production servers to create new evals or etc. And then enforcing behavior from there. Because if like whipping your agents to do the right thing is really hard. I don't. There is no absolute truth to doing this. No one has. If people would have figured it out, that would have been visible. So yeah, but really, really good evals that mimics production behavior that is easy to run in your code base, preferably through a CLI, and you can give that to your coding agent of choice so they can help you in working with those evals.
Yeah, but like if you have external services that you need to somehow mock, but that are unpredictable in themselves, like a search online, for example, or on a GitHub repo. Or
Yeah. I think, like you mean in the testing?
Yeah, in the end-to-end testing.
Yeah, and I think in end-to-end testing, the point is to not mock those, and try to get your external services to be as predictable as you need them to be. If you need to be unpredictable, then you test that. And here, I mean, it's not a religion. Sometimes, for instance, in our component tests, we mock all LLM calls, because getting those to behave, that's evals. That's another problem. So here, by external services, we can say predictable external services. So not to get LLMs to behave correctly, but to get your coding agent to be able to iterate on your code base really, really quickly. Any other questions? Good, more time for pizza and beer. Thank you very much.
Thank you all for coming. You're free to stick around.